Hello everyone, NadLabs here. Today we're going to be making this Boid simulation in the Godot game engine, version 3.2.3 stable, and yeah, let's get right into it. So just before we get right into it, I just want to explain a couple things, and that is that we are going to be using Area 2Ds. As you can see that it says Area 2Ds over here. The second thing is you don't need a very good computer to run this. In fact, right now I'm doing a simulation with around 50 boids. Yeah, I'm just running a simulation with 50 boids over here, and it's working perfectly fine for me. And that's about it. So now let's get right into making this. So you can see that we have a couple things in our game scene, and the game scene is just going to be the parent scene, the root scene, the one that we need to run the game on, and that's actually the one we're going to be, this is actually the scene that we're going to be running for the project. As you can see, I can click the play button, and everything starts working. And then we have a tile map. So you can see that this tile map has a bunch of little black squares, but in my assets folder, there are no little black squares. The reason being is that I actually used the Godot icon, and I actually zoomed into a very tiny part of it. So I can actually show you how to get this little black square just from the Godot icon. So you go over here to new single tile, and you just drag over our region. Then you can see that the snap option showed up. We go over here, and we can just type in something like 8x8 or something, and just click an area that's kind of like one color. I found this top left corner works, or maybe this top right corner, and you click it. You set a collision shape over it, and I should actually zoom in. That's really small probably. Sorry about that. And you can see that we zoomed in, and we have this little tile over here. Go back, and I have another tile, and it works the exact same way as all these other ones. And that's really all there is to it, to making a collidable tile set. And the reason we need this is because we want to have some terrain that are boids, which are those fish simulation creatures that you saw at the beginning of the video. We need something for them to navigate around, or else it's really boring. We also need a boids folder. We need a camera 2D, and we need a timer. That's all we really need. And then after setting up your game scene, we need to go into our boid scene. So you can just click a plus sign over here and start making the boid scene. So what I did was I made an area 2D. The sprite is just a triangle I made, nothing too special there. We have a collision shape which covers over the actual triangle. Sorry about that. Then we have a vision cube, which is actually going to be a collision shape around this big, and I'll actually explain why we have to make it a square and not something else. So when I was researching how to make boids in the best way, I found that a lot of people, wrong tool, a lot of people would say, okay, let's say this is our boid, it has some vision, and of course this vision is on, like the eyes are on the side of the head, so it has some vision like this. It can see back here, kind of. It can also see like in front of it, so all of this area is covered. So we can basically say this is the field of vision. Some people also said that let's just assume that the boid has perfect vision, and it can see directly behind it as well, right? So it would fill in this part, and this is a horrible circle, but you get the idea, right? Basically, the boid has perfect circular vision, maybe a little bit more at the front, then less at the back, and in Godot, this is totally possible. You can do a circle, but at the same time, if we abstract what this really is telling us, we can see that, let's just do a, let's do a pink color. You can see that we have a corner. We have a corner over here, kind of, and then we have a main point over here that's far. Then we have a point that's farthest away from the eyes, which are, let's say, like the middle of the eyes, which is right over here. So if we abstract this out and we say, let's just split this up so it goes over here and over here, then over here, a rectangle which is a little bit ahead from the center of the boid. So maybe the center of the rectangle is right here. But essentially, it's still a rectangle. And the reason I'm doing a rectangle is just because it's really easy in my experimentation for Godot to work with rectangles over circles. And that's why I decided to do that. And that's basically all I have to say about that. So after that, you can see that we have these arrows over here. These arrows are actually in an array folder, which is just a regular old Node2D. You can see it says type Node2D. And we have a bunch of Raycasts. So in reality, we don't need all these Raycasts. As you can see, this one's disabled. Or actually, it's not enabled, so it's kind of disabled. We have this one. Okay, so we don't actually need these two. I can just delete them. We basically need two Raycasts, and this is to help with computation on slower machines. You can see that we have one that goes onto the side. Let me just get rid of this collision shape. We have one that's going onto the side over here, one over here, and we have two that are in the middle. And they're kind of pointing forwards, but one is longer than the other. This is just so that, let's say they were actually the same height. So let me just make them the same height. So let's say they were the exact same height, and a block apparently just came up right around it. So we have let's say this is our block. Like one of these walls over here, let's say it like was trying to go up against here or somewhere over here, and it just came up against it, the boid over here would have it would be a little bit harder for the boid to move, because it's like, what do I do? I'm surrounded, but like both of these arrows are telling me to go backwards, and it's kind of like, it's just kind of weird for the boid to be in that sort of position. So sorry about that flash. So basically what we have to do is we have to make one longer than the other, so when it actually hits that wall, it's like, oh, okay, I'm going in this direction. It kind of does bias our boids to moving in a certain direction all the time, but I found it's just a little bit easier. Of course, you can do it both at 60, or in my case, it would be, both of them would be at 60. No, that didn't work. Both of them will be at 60, but you can try and experiment. Maybe it'll be better on your computer or your machine. And that's basically all we have to do to set up our boid simulation. And let's get right into actually programming. So you can see that I just attached a script to my boid. So I just went like that. And of course it'll say load, it will say create for you. It says load for me because I already have it. And all we have here is extends area 2D. We have a couple variables, and I'm going to explain what those are. And there's one last thing I forgot to mention, is that we actually have to go to our boid. We have to go to nodes, and we have to click groups, and we have to give it the group of boid. Those will become apparent later on. And that's basically all we have to do. So what we're going to be saying is we're going to be getting a couple declarations to our variables. Of course, we're going to need the array folder, right? And we're going to actually be saying get children, so it returns an array. And if you don't believe me, it returns array. It just says get children, returns an array. And it says returns an array of references to the node children. So that would be those. It will be an array of those Raycast 2Ds. We also have Boids IC. So this is an array of the fish that this area 2D, which this one can see. So everything, every other triangle that's inside of this blue box, whatever is inside this blue box, will be picked up by this fish boid, and it will basically be saying, okay, you guys are in my area, like radius or box of vision, and I will be taking your velocity and doing some calculation with your position just to fix my velocity and position. Then we have a global variable of velocity, and I just said that we actually need reference to those triangles. So you can see that we actually need these triangles references, and we're actually going to be getting their velocity. The only way we can do that is by saying velocity is a global variable. We have speed as a global variable, screen size, and screen size has to be declared here because it doesn't work well in the ready function. And we have our mod variable, and I'll explain this. It was just for experimentation that I made this a variable, but it doesn't have to be. I just made a full screen, and then we're going to say in our ready function that we're just going to be saying screen size equals get viewport rec dot size, and then we're going to say randomize. The reason we're saying randomize is because we're going to be using a couple random functions, so we just need to make sure that we don't get the same numbers each time. In our physics process function, we're going to be saying a couple things. We're going to be calling this function called boids. We're going to be calling this function called check collision. We're going to take our velocity, we're going to normalize it, and then we're going to multiply it by speed. The reason we're doing this is because if we didn't, and you can see these are just some boids, you can see everything's getting faster and faster and faster, and they're actually not slowing down because I never normalized it. Now this is a completely different example, and this is not part of the tutorial whatsoever. Well, I'm just showing you that they'll just keep on getting faster and faster until their numbers get so high that it will just cause a crash, because modern computers can only go to such a high number. And of course, it will take like maybe a couple weeks to get to that number, or maybe days, I'm not sure. But basically, this will get so fast to a point where the computer cannot calculate their speed anymore and crash. So let me just hop back into that project. So now we have so now you know why we have to normalize and multiply by speed. Then we're also going to call this move function. We only need it if we're only going to need this move function if you plan on doing something where there's no walls on the sides. But I found it looks a lot nicer if there are walls, so I'm going to keep that there. And then we have rotation equals this lerped angle, or linear interpolated angle, and we just have rotation. We're just taking in our rotation, and we're going to be saying velocity.angle to point vector 2.0, and doing it by 0.4. What this basically means is we're going to smoothly rotate to where the new rotation is going to be, because we're saying velocity.angle to point vector 2.0. That basically means that we're saying, let's say we're heading in this direction, and then suddenly, because of neighboring boids and everything, we have to go in this direction. Actually, this direction. What we're basically saying with this lerped angle is we're going to be moving like this. So that'll be the first frame, second frame, third frame, fourth frame. And then we're going to be able to actually point our boid in this direction. I'm very sorry for the inconvenience for this showing up red. So let's actually declare those functions. So in the order I defined them, so boids, check collision, and move. And I actually filled in the move function with just a little bit of boilerplate. And basically I'm saying if global position.x is less than 0, set it equal to the other side, which is screen size.x. If it's greater than the screen size.x, which is the right side of the screen, set the global position of that fish or boid to the left side of the screen, and same idea for the top and bottom. This is just a really simple movement code for defining how your fish would move or boid would move. If it hits the right side of the screen, you want it to magically appear on the left side of the screen, and if it goes up, you want it to magically appear at the bottom of the screen and continue swimming. That's basically all we really have to say for move. I'm not going to explain that too much, but the main meat here is boids and check collision. These are where we're going to be doing all our calculations. But before we get to those really meaty parts of this code, we're going to have to say a couple things about the Boids IC array. And the way we're going to be discussing them is by actually going to our vision cube, which is this one, and we're going to be saying to the signals, we're going to connect, and what I'm basically going to be saying is we're going to be going to our vision cube over here, our square. We're going to be saying connect this signal. So you can see that it was I already connected it before, but I'm basically connecting it again, so it'll look like this for you. And then I double click it, click connect, and we have our on vision area entered and on vision area exited. The reason we need these functions is because this is how we're going to be detecting whether something enters the vision box or if it leaves the vision box. So quite naturally, if we're detecting if something leaves or enters the vision box, we have to say if the area is not equal to ourself and if the area is in group boid. If you remember, we all went over here, we defined all these boids to be in the group boid. Let me just get rid of this big triangle. And you can see that we're in the group boid. So if we're in group boid, then we're going to see boids IC.append, which is just a method to add an element to the end of the array. We're basically going to be saying add that area. So in our array, it will be in the array, which is like this. We're just going to be having a boid, another boid, another boid, another boid. And of course, they're not represented by ones, but you get the idea. We're just going to be having a bunch of boids. And the strength of this approach, in my opinion, is that we only have to focus on these 4 or 5 or 6 or 10 instead of the 100 that we're actually working with. We only have to loop over this array, not all the boids in the scene, which is what a lot of videos I watched. They said, oh, we're going to loop over every single boid, and then we're going to check distance and blah, blah, blah. I just find it better if we're only looking inside this box that we've defined, but that's just me. And then we're going to say if a boid or a fish or a bird leaves our vision area, well, what are we going to do? We're just going to be saying boids IC erase. And erase, we have to use erase because we're basically saying remove that specific example. And we can't just say pop or remove the front value. We can't say something like that. We have to say erase that specific value because that specific boid just left our vision. We can't say that a random boid left our vision. That wouldn't make much sense. And the reason I'm saying if area is because Godot will scream at me if I don't use it. You can see it already is screaming at me for a couple unused variables. I don't want any more of these like triangles, but whatever. That's just my opinion. And that's basically it for the helper functions. We can now move on to the function of the boids. And let's start off with saying if boids IC is true. So basically we're saying if there is something in my vision, let's start off with that. So if there's something in my vision, what do I want to do? Well, I definitely want to get the number of boids I see, so that would be really helpful. I want to define an average velocity, average position, and average steer away value for all these boids. And the reason they're vector 2.0s is because the velocity is a vector 2.0, and this average velocity, although it's not meant to be 0, we're starting off by just declaring it a variable. This colon over here that you can see that I'm putting in a lot of places is just to define the type. So this is equivalent to saying this. Godot recognizes it's a vector 2, and we don't have to define its type. And then we're going to make a loop. And we're basically going to be saying for boid and boids IC. And what are we going to do with each boid? Well, we're going to be modifying our average velocity. We're basically going to be saying average velocity plus equals boid.vel velocity. Vel, I guess you could say. Average position is going to be equal to boid dot position. So that'll just give it the position relative to us. And if you're saying, hey, well, that's not an average value. That's just a total. Well, we actually have to divide it by the total number of boids. You can see divide equals it's just like saying is equal to average val divided by number of boids. So that's the equivalent statement. But it's just a lot neater if you do this. And we're basically going to be saying to our velocity, which is defined up here, and how we're actually going to be moving, we're basically going to be saying velocity plus equals average velocity minus our current velocity divided by 2 to get the average of that. And we're also going to be saying for our average position, we're going to be doing the same idea. So we're going to take the total number of those positions, and then we're going to divide it by the total number of boids. And then we're going to be saying velocity plus equals average position minus position. And I did a lot of experimentation. I found this works the best. Other YouTubers and other videos I watched say differently, but I found this works the best on Godot and the approach I did. So you can play around with it and experiment with this is what I did. And I just want to, and if nothing makes sense, just remember you can comment down and I'll make sure to respond. But I'll try my best to respond. And if you're wondering how velocity is going to be moving our boid, well, basically when we're saying in our move function, global position plus equals velocity. The reason we're doing this and not saying something like, move and slide, which is found in the kinematic body 2D, it's literally because we're using an area 2D. We're extending area 2D. This boid over here is area 2D. It's a lot easier for Godot to work with area 2Ds as compared to physics bodies. So that's something we're just working with. And another thing you might be wondering is, what the hell is steer away? Why do we have to declare it? Well, I'm getting to that right now. Steer away is kind of a complex line, but I'll try my best to explain it. So steer away is basically going to be equal to boid.globalPosition minus the global position of ourself. And we're basically going to be saying, multiply that by a factor, which is going to be equal to the inverse of the distance between us. So that's really complicated. What does that really mean? So as you can see, we're running this simulation with our boid, and we have all of these things being activated. And you can see that we have these like fairly typical boid movements. You know, so everyone's bunching up in groups and everyone's moving around. It gets a little weird at the edges because we're only looking at our radius or our box, and they can't detect people on the other side. So that's one limitation, but hey, at least it works. So you can see that if I get rid of this and this line and I click Control S, everything gets saved, and now everyone is updated, like their movement is updated. I didn't have to rerun the scene, and you can see everyone's keeping away from each other. That's basically what we're saying. We're saying that the closer you are to a boid, subtract that value and make sure you stay away from them really well. So you can see that I can't really show one specific instance because they're moving so quickly. But if you like focus on one specific boid of your choosing, you can see that when they get really close to another boid or fish, they basically move away really quickly. But if they're kind of far away from them, they don't really care about them until they become much closer and, let's say, a bit bigger threat to their existence. Let's say if you couldn't touch anyone, then they move away really quickly. So it's kind of like social distancing, but on like steroids. So that's basically what happens if we're running this steer away command or line. If we run something like align ourselves with people moving in the same direction, it's almost kind of visible that they started moving towards the right, or it might be just a figment of my imagination. I'm not sure. But if we run all three of these lines all together, you can see that we start moving in a boid direction. Now, why is that? So let's say we get rid of these two, and we're only going to be steering towards the average velocity of other people. So we're going to be taking our average velocity of our nearby fellow neighbors, and we're just going to be saying, just move in that same direction. So hypothetically, I haven't seen the scene yet, but we're basically saying that we're going to be moving in the same direction as everyone else. Everyone should be aligned. But let's say we want to move in the same position as everyone else. So we're basically saying move towards the same position as everyone else. And let me just Control S, run that scene. And you can see everyone is literally on top of each other because your average position has to be equal to each other. And that's basically what we're saying. And that's what happened. So you can see if I let everything go, they're kind of like starting to fade apart. And of course we get a division by 0 error. That's one thing I was expecting. That often happens with this because, or not often, really rarely happens. And it only happens in these edge cases where you're playing around with it. Basically what we're doing over here is we're saying global position minus boid.global position, and that might lead to us having two boids directly on top of each other, and that's really rare to occur, but it can occur, and basically we get a crash. Not to worry, if you run all these three rules, everything works out and we don't have to worry about those crashes. But at the same time, if we do something like this, you can tell that we didn't have our nice aquarium scene over here running. I want my boids to go around. Sorry, let me just get rid of the orange background. We want our boids to go around like this. We don't want them to be like moving randomly around the scene. That doesn't mean anything to us. We want to see actual boids moving around and fluidly going around rocks and like splitting up and rejoining, like cool stuff, not boring stuff. So then this is where the check collision function comes in, and this is where the Ray folder comes in. By the way, if nothing I'm saying is making sense, I highly recommend you guys go check out Coding Train Boids, and you can literally search up Coding Challenge number 124, Flocking Simulation by the Coding Train. Amazing guy, love this guy's videos. And then also you can get, probably this will come up, Coding Adventure Boids by Sebastian Leg, and he's a really good video on making boids. You can see he also does 3D ones, which I'm kind of working on, by the way. But yeah, that's basically these two videos really helped me out, and I highly recommend you guys check this out if nothing I'm saying is making sense, because this is where I went and learned stuff. But they didn't do it in Godot. This guy did it in JavaScript, and this guy did it in Unity, C#. So I did it in GDScript/Python, I guess you could say, but whatever. Let's go back to our check collision function. So, and by the way, this is just a really quick way to loop over a bunch of arrays. You can basically say for array and array folder. And then remember, array folder is actually going to be array folder.getChildren. So we're actually getting the array of all of these. So we're just basically getting an array of all of these arrays. I just want to repeat that because I want to make sure that makes sense. And we're going to do a couple things. We're basically going to be making a variable called R. We're going to set it to the type of Raycast 2D. And we're going to be basically saying for array and array folder, make a variable called R and set that equal to array. The reason we're doing this is because now we get static typing. So you can see if I type in R dot and then I get like is colliding. You can see that I basically get documentation now. I can get all of this stuff over here, and I don't have to memorize that or like hope it works. I know it will work, so I can do force raycast update. So R dot force. You can see that I get the static typing, but if I do ray dot force, it will like I have no clue what you're saying. This doesn't make sense because ray to Godot right now is any variable. It doesn't have a type. But R has a type. It's Raycast 2D. And this is where that colon, sorry, I should have made that bigger. This is where that colon syntax comes in. So basically what we're going to be saying in this check collision function is that we're going to be saying for array and array folder, we're going to make a variable called R. If R is colliding, we're going to be doing something. What are we going to be doing? We're going to be checking if R.getCollider is in groups block. What do I mean by blocks? I mean that this tilemap over here, this tilemap has a group. And I didn't mention it, but has a group of blocks. That's important because we want to make sure that we're colliding with a block, right? We want to make sure we're colliding with a tilemap. And this is one simple way you can do that. And then what do we want to say? Well, we want to say something like, if the boid is like, let's go back to paint. If the boid, let's say this is our boid over here. Hello, why are you not joining? Okay. Let's say our boid's like that. And let's say this is one of the raycasts that's shooting out. And no. Let's say this is one of the raycasts that's shooting out and it's hitting this wall. We basically want to say, whatever raycast is actually hitting this gray wall, we basically want to say, move in the exact opposite direction. So let's say the boid still doesn't pick it up, or maybe it's not like fully there yet, or let's say there's another wall over here, right? Let's say this raycast, nope, that's a horrible raycast. This raycast over here is pointing this way, and there's actually a collision intersection right there. We're basically going to be saying, move in the exact opposite direction. And because we're taking our average velocity over a bunch of instances, we're basically going to be moving in the resultant, which is kind of in that direction over there. And that's basically where we are going to be moving. So let's implement that. As you can see here, we have a variable called magi, or magnitude, which is going to be equal to some value. Just don't worry about that yet. We're basically going to be saying velocity is going to be equal to R, so raycast, or the ray, dot cast to dot rotated rotation times magnification. That is a whole bunch of baloney that may not make sense to you, so let me explain that. We're basically saying, get r.cast2. What's r.cast2? r.cast2 returns a vector 2, and it's basically the ray's destination point relative to the raycast position. That's important, the raycast position part. The reason is because r.cast2 basically says, oh, okay, so you want me to get you this value over here of this ray? So this ray is kind of like 70 points this way and maybe 5 points up, so yeah, I'm going to give you 70 and 5. But that's not what we want. We want it to be like this. So for example, let's say our boid's kind of like pointing like this. Our boid's pointing this way. And now our raycast is actually like this. Our raycast is actually like this. But in reality, Godot still thinks it's like this. Godot still thinks it's like that. But that's not correct. It's actually like this. It's like downwards kind of. So we actually have to rotate it by our rotation. If you're wondering why rotation, or what is rotation, well, we can control click it. And you can see rotation is just rotation in radians. So relative to the node parent. So that's like, it's just a rotation of our current player. So if I went like this, hello, if I went like this, it's just basically getting that value. Let me go over here. You can see I'm basically getting that rotation value, but not in degrees, in radians, which is a lot easier for computers to understand. And we're going to be multiplying it by a magnification value. This magnification value can be modified by you. It can be anything you want it to be, but just remember one thing. We're going to be saying r.get collision point subtract global position dot length squared. The reason we're doing this is because we want to make sure. Actually, you know what? Give me 1 second. What this line of code basically means is, and I'm sorry, prepare your eyes. I'm about to go into a white mode, like a really light themed website. Sorry about that. It's called decimals.com/calculator, and basically you can see that this is what the graph looks like: 100 over x squared. I'm sorry, I have to go back. Actually, can I do this? Kinda ish. I guess kind of works. Yeah, it works like this. Okay, so we're basically saying for our Maggie variable or magnification variable, we're basically saying 100 divided by some value, and it's basically x squared. And you can see that the closer this whatever whatever that is, that's x. And I can actually show you 100 over x. We'd be getting something like this, but you can see that this is a negative value. We don't want that, so we have to square it. And that's basically what we're left with. So the closer that block is, the closer that blocks is to us. Hopefully you can see my mouse circling that blocks text. The closer that block is to us, the more we want to be pushed away from it. Because you can see this magnification variable is like maybe 65. If we're multiplying by 65, if it's like 1 pixel away from us. But let's say it's 20 pixels away from us, or 12 pixels away from us, we're getting 0.69. Nice. So that's basically what we want to be saying. The closer we are to something, the more we are pushed away from it. The farther we are from something, or the farther away this collision point is. So this one might not have as much an effect on this purple average overall velocity, but maybe this one, which is really close, it will have a greater effect. And maybe the overall result is that we're moving more this way, because we have to get farther away from this gray wall up here rather than this one far away. That's basically. Hopefully I'm making sense. If not, maybe rewatch the video or ask in the comments. I'll try my best to respond. And that's basically what we're saying. And we're basically done. I don't see anything else, but you're probably wondering, how do I get the boids to spawn? So basically what happened was I went over here into my game scene and I attached a script. And you can see that this script is pretty simple. So if I just do that, this script is really simple. We're basically saying on the ready function, we're getting our screen size variable. We're saying randomize. And we're saying for I in a number. This number is an exported variable, and I can go over here if I hop out of distraction free mode, and I can actually change that on the fly. So we can have like 500 boids, or like don't do a negative number, but like 22 or any number I want from here. I don't have to keep changing it in code. Really saves me some time. And we're basically saying spawn boid. Well, what's the spawn boid function? Well, the spawn boid function is kind of simple. It says make a variable called boid, and we're just going to be saying instance it. So preload the boid.instance. We're saying get the boid folder, which was over here, boid folder, and we're going to say add child boid. And after that, we just want to change its color to some random color so it like looks more pretty on our eyes. And then we're basically going to be saying boid.global position is going to be equal to some random box. And let me explain what that box is. So we have let's say this is our screen, right? This is our purple screen. And we're basically going to be saying, just spawn them in this area over here. Not on the edges because we don't want that, but just somewhere in here. Just somewhere in here. That would be really nice. And we're basically saying that. So we're going to be saying 0 plus margin. What's margin? Well, margin is a variable up here, which defines how close do we want on the inside. So if we go to 100 pixels, so somewhere over here is around 100 pixels. So we're going to be starting from this corner all the way to somewhere over here. And inside this box, right, like maybe like these grids over here, like just somewhere in here, just spawn a boid. And that's basically what we're saying. So random range from 0, so basically from margin to screen size.x minus margin. That basically means from here-ish to over here. And if I go over there, so you can see on the y, this is the y, after this comma is the y variable, and or the y position. So you can see, again, we have margin. In fact, I don't even need 0 plus. And then we have a screen size.y minus margin. And that basically means start from over here somewhere and go all the way up to here. And that's all you really need. And I also have a timer over here. I didn't really want to mention that, but we just have a timer over here which spawns in boids if they die. How does a boid die? Well, we'd have to say a boid would die. How do we do that? Well, we could say, we go over here to our signals and we say, if this boid enters a body, we can do if body, and we say print hit something sad face. And this would basically call the death of the boid, but since it looks really bad when that happens, and I'll show you, it looks really bad, so I didn't want to keep that in there. But essentially that's all we need to do to run a boid simulation, and you can see legs for a little bit and it starts working. And that's really all there is to it. So does this work? Let me just check. And you can see that whoa, okay, it crashed. Oh, I went to 1000. Okay, never mind. But you can see that these fish kept hitting something. They kept hitting these black squares. And imagine if every time this was printed, one fish was removed. We'd basically end up with 0 fish later on. But hey, it looks like they're not hitting it, and that's all that really matters. And oh, do I have 100? Okay, 100 does not run on my computer. 50 does, as well. And because I'm recording it, I have to do it like that. And basically, yeah. So we have a bunch of boids swimming around. If any issue comes up, just let me know. I can try helping in the comments. And that's all I have to say for this tutorial. Again, check out the resources. I'll link them in the description. They really help me out, and I really think you should check them out as well. And that's it. So you can see that they're clumping up together, but when they hit areas like this, they split apart. They go over the rocks, and I thought this was really cool. I had good fun making this and recording a video about this. They kind of do jitter around the edges. That's one thing I'm kind of working on, but at the same time, they still look like fish. Like the overall effect is that, hey, these look like some intelligent fish creatures. Like they're just moving, and they're like being able to recognize who's around them, move the same area, and moving the same velocity and stuff. And yeah, that's basically all I wanted to say about this. Have an amazing day, and code is in the description below. If I ever make an update about this, I'll definitely do another video. And that's all I have to say. Thank you very much for watching.